Hello, welcome on DevOps Live, the third part of the series for DevOps meetups, hosted by Gravity 9. And this time we'll talk about enhancing Kubernetes security. And because as we'll find out later on, Kubernetes is not secure at all when you set this up for the first time, but we'll find it out later on. Couple of words about our company. We're Gravity 9. We're a software company helping other companies to evolve, especially with adaptation migration for legacy systems towards new application patterns like microservices, Kubernetes, and cloud. We are located in, around the globe, offices in Poland, the UK, US, Colombia, and even Korea. But let's talk about the Kubernetes security. So the Kubernetes, as you know, there is just revolutionize the way how we deploy and manage containerized application. However, how powerful it is, Kubernetes doesn't inherently is secure. So, in order to provide this on the level of the enterprise-grade application, we need to add some additional work to make it more bulletproof and enhance it to the level that is doable against attacks and threats from the outside and inside as well. So about the introduction to Kubernetes security, so it's like Kubernetes secured by default. As it's very adopted for container orchestration and with all its benefits, its rapid development and implementation and scaling capabilities, it's not secured by default. So this is very important to implement security measures in order to have it secure and prepared for deployment publicly. So the challenges for Kubernetes and security is that the default configuration, whenever we create a new cluster, is try to prioritize ease of use over the security. And in order to rapidly deploy something, configure it doesn't always mean that this is do not do enough. So that would require additional steps to make it secure more that we can expose it. Also, like configuration for security-wise configuration is quite complex. It requires additional resources and products that need to be added to plugins Kubernetes. So that also has a bit of knowledge and reading of learning. With that, with setting up a Kubernetes with default configuration, there is a huge risk that we will expose sensitive data available for potential attackers. But if you want to start thinking about security, the first thing that we can do is block the traffic, because Kubernetes itself doesn't give us any protection if we are deploying application. This is especially important when we have clusters where we keep our environments in one cluster. So we have a separate namespaces, and those namespaces are related with lower environments like development and testing, but we also have in the same cluster production environments where we have sensitive data and configuration. When we set this up in this manner, there's like always possibility that we can connect from one service to another. So imagine that you are an attacker. If you're able to break into the lower environment, which are usually less protected, you have like open door to any other services in the same cluster. And with that, it's opened the window for vast ways how we can attack and pull the data. So this is right now very important to deploy something that's called network policy, which is not implemented by default. So by default, Kubernetes is like allowing both interaction between namespaces and within the whole cluster, even between the nodes. So in order to protect our Kubernetes, it's good to have network policy set up upfront. And network policy is a rule that will give us the power to block communication, and it's pretty flexible. So we can block the communication between single pods, or we can select a set of pods, or even like namespaces. We can block ingress and egress traffic. So it's very capable, and that's the first thing that actually we should set up, because with that we can make those areas with strict boundaries how the communication should look like. And if we need more advanced techniques, like the network policy is not enough, we can move to service meshes, which put another layer of communication between the services. And there are a couple of products available on the market. One of them is Istio or Envoy. At the end, we add another instance of the service as a sidecar, which will cover all the traffic to our pod, so we can add some more advanced routes. But as a starting point, it's good to have a network policy. Here on the left, there is a sample network policy that will deny all the traffic from other namespaces, so the selector is empty. But with that, we are blocking the complication. Once we get set up the network and traffic, the next thing where we should look at carefully is access to the Kubernetes cluster. By default, whenever we deploy Kubernetes cluster, we'll be using Kubernetes airbag configuration, and with that we'll have one service account that will have admin rights and privileges that will be exposed. So with only this one account, it's very hard to gradually spread that across departments. So imagine that we have a developer, so we want to give them access only to one namespace or set of services that you can actually connect to and do some diagnostics. But we don't want to give them access to other namespaces where we store more crucial data or configuration of our secrets. With default configuration, this is pretty hard to cover. But there is a way how we can solve it. Vendors that provide managed Kubernetes services usually also provide their own mechanism for dealing with authentication authorization. And with that, we need to use the local airbag system. With that, Kubernetes and make a bridge using the Kubernetes local airbag, creating service accounts, role bindings and roles. And with that, we can build that configuration that we can limit access to Kubernetes resources. This is also nice approach as we can integrate with the identities that our vendors are exposing. So Active Directories with single sign-on, we can also connect to it. So users use his domain account, and with that domain account, they can connect to Kubernetes cluster. And with the roles and the groups, we can also limit the visibility. Another area that is also very important in Kubernetes is how we treat with secrets and configuration. There's always part of the configuration that we want to hide. Usually we store that configuration in vaults, where it's managed by engineering, and we don't want to expose it. So also we protect it is the way how we manage it, the way how we configure it, so there are processes around it. So it'll be wise also to think about the process, how we then inject that data into Kubernetes, so it's also protected. And the standard approach is that we, using the pipelines, we provide the data, pull from Vault and decorate the deployment with secrets, usually as environment variables. But then be not sufficient, and whenever someone breaks to our CD pipeline, may actually get in the possession of those secrets, which is a huge threat. But there are other options of how we can solve that. One of them is to use secret protection with SOPs. SOP is a short form of secret operations, and it was also good with GitOps. And the design for it is that we encrypt our secrets, storing Git repository. The encryption key is stored in the Vault, where only a limited number of accounts can access to it. And one of those accounts is assigned to Kubernetes. Kubernetes can actually decrypt that. So storing the data in Git repository requires also the knowledge of the key which was decrypted. So and also position of the service account, so that it becomes harder for the attackers to actually break it. So and the flow looks like that someone is, or the party or department is encrypting the essential data with encryption key stored in Vault, and then Kubernetes using the same key to decrypt it, or part of keys to decrypt it, and pulls the encrypted data from the repository. And this approach is popular because it's also agnostic. So majority of the cloud providers provide the mechanism to use key encryption, and with that, migration from one vendor to another is simplified. Once the file is encrypted, the YAML spec file will look something like I have presented here on the screen. So it will have this enc prefix, and then will be followed by an encrypted data. Another approach for storing secret data is to have a bridge between Vault and Kubernetes cluster. And those resources are called container storage interfaces. And they are responsible for integrating external Vaults with secrets in Kubernetes. We know that secrets is a placeholder where we can store our show information, show data and configuration. So we have Has she talked about AWS Secret Manager or Azure Key Vault? And all of them are provide the CAI storage classes where we can implement and configure. And with that, we can connect those secrets with our Kubernetes clusters. So I think that in a nutshell, those are the three things that we need to take care of, but this is not the end. There are more and more that need to also be provided and configured. Also, as a best practices, what is important is to update regularly Kubernetes with the latest version. It's also important that the cloud providers usually give us a window time we know where we do it. Otherwise, we need to set the cluster from the scratch again. So it's important to keep the updates somewhere in memory or in calendar. Also, tools that you can enforce network policies, which I mentioned before. So we have that enabled, and with that, we know that always enabled, and maybe by default deny all the traffic, and just get later on opens on consumer ports and services. And use that airbag with immediate permissions that we can set up using external providers, because Kubernetes by default doesn't give us that option. As we covered, encryption of secrets is also important, or providing the glitch to the files when we store them securely. And something that I didn't mention is to monitor everything. So also Kubernetes just expose events, but they may not give us the full data or insight. So additional tools on the like Grafana or can use vendor-specific tools to check out if our cluster is secure. Thank you. Now we will move to our demands. In order to deploy resources that I have covered in the presentation, there are some significant changes even in Terraform scripts that have did that for previous sessions. And here is the comparison between those two files. We will start with Kubernetes cluster configuration. And the first thing that is notable that we are adding a service account in Azure and user managed identity that is assigned to Kubernetes cluster. And in order to have that notion in Azure that represent the Kubernetes needs. So that's this part that is configured here. Other important thing is that we open the IDC issuer, a new cluster. And also we are the key vault secrets provider. This is a CSI that I covered on the presentation. So we want our Kubernetes cluster to be able to connect to Vault and grab all the secrets that are needed for our services from configuration. The part with the roles-based access control is rated with airbag. So we are enabling Azure airbag authorization instead of native Kubernetes, and those two identifiers, GUIs, are added with admin accounts that were added so they can have access to this cluster. In order to enable the network policies, we need to also enable it explicitly because, as I mentioned, by default we don't have it. So here we're using Calico, but there are other tools, other vendors that are also, I believe also Azure is one, which may be more performant. But we use Calico. One of the CNI that is present on another first time. Later on, there's just configuration for the manager identity, as well as to provide a way that we can have the federated credentials, which are pretty handy because it's secretless, so we want to provide secrets, and Azure is able to authorize some requests without storing any secrets on the client side. And the last change for Kubernetes is that in order to make any changes for meetups, we are just exposing different admin and comment for our vote to start. Regarding changes for our foundation, where we configure votes, accounts, and resource groups. There's also a slight change that we have added the key vote to store our data security, and we will also give permission for our managed identity, so we can grab the data or Kubernetes grab the data, because before the comparison, there was a service receiver, it's assigned to Kubernetes. Here is a configuration that this service receiver can actually get in the list and set the secrets. So it will be able to put that data, and it will, at the end, we are also adding one entry to that key vote, so in order for them to show up at this vote. In order to prepare for the demo, there are additional resources that were added to our GitOps configuration. One of them is that there is additional namespace, which we want to secure, so it's called domain, and we have one PAI deployment. That's deployment where we are holding our service that is crucial, so we want to prolong the access to it. Another change is that there is hold as an example, which will pull the data from the vault using the bridge of CSI bridge. And it's configured with the application, so namespace. And with this configuration, we have one environment variable that is pulling that the data from the secret. So we hope that we will grab the key secret source from vault, and the value for it is stored here. On the bottom, we have one key secret source with the value such a 1. So moving to Kubernetes itself. Let's first look at the network policy. Whenever we create that resource, and that despite of the tools that we are using to navigate Kubernetes, we should have it on the network, and there will be network policy. So there should be our network policy, which we have created. Our deny from other namespaces is deployed on namespace domain with no additional configuration. So we're expecting that other pods shouldn't be able to access to it. So, and in order to present to it, let's open terminal. Let's try to grant pod strong application in space. This one. And I will try to comment to it. Open shell. So I am right now adding in React app form flags. It's checking everything. Yeah, ping is present, so we can test the connectivity. So let's try to connect. Let's set the connect to visibles. Grab the IP of that code. Yeah, the connection is there, so you can go into the box. So, as I mentioned before, there is connectivity. But how about checking if we can connect to our domain service? So our PI service is located in namespace domain. Whenever we got the details, there will be an IP address. Let's copy that IP address and try and ping that. Okay, trying to ping, but as you can see, there's no response, so probably our network policy is working. There may be a timeout for 1 minute, but we can leave it. So later on we can return to it and see that there's timeout. And regarding CSI and pulling the secrets from key vault, there is a pod that has configuration and to pull that data. So the way how it's configured is not trivial. It depends on the vendor, or we could go through the specific configuration. The documentation is not so solid, so that requires some effort to set this up. But once done, and we'll just repeat the same process for other secrets. In the situation that requires some custom resources, and our custom resource is here, so secret store CSI. And we have as of saying secret provider class that it will be configured, and again, documentation not always well thought and present, and sometimes the specification is a bit odd. So here we have objects that we need to set as an array, which maybe hard to read and sometimes requires some digging, but at the end it's working. So once we go through that, later on we can repeat it. Maybe one drawback is that we need to explicitly mention all our secrets that we want to pull. So whenever we are introducing a new value, we need to add the configuration here, which may be somehow automated by some scripts, but yeah, I'm expecting that the newer version of those drivers will give us like more options, so we may become more flexible. Well, when we set this up, and then we also configure our managed identity with the federated capabilities. Whenever we create a pod, the pod that we want to give it the possibility to pull that data from the key vault. Whenever we set this up properly, and if we configure it and provide a driver, and also inform that from which it should pull the configuration for our secret here, and our secret Kubernetes. At the end, we should see our value. So if I open shell for that pod, if I open environment, so they should have my secret source set to 1, which is the setting as here. So the value was pulled from the vault without CD pipeline where we inject into the configuration. Our ping is still trying to connect to window. As you can see, we wait a couple of minutes, nothing happens, so then definitely not So we try to send 239 packets and 0 was received. So the communication is blocked. And then the last part of the demo, that's to do with airbag, and we'll also send logs and bindings. So we have our application namespace where we store our configuration for applications, and we want to give developers access to it. So this is our role. So we want to give access to apps and extensions, so all of them, and through resource like batch, jobs and cron jobs, and deployment spots. But we want to limit it only to one namespaces and this application. So that's the namespace application, and so that that user that will be assigned to that role is not able to connect to other namespaces. Then we need to make a customer binding, and this is also connected to some below binding. This is also. And we also need to connect to once we set up roles, then we need to create a role binding. So our role binding, for this example, is connecting to Azure, and I'm using here our role application user full access, but and it's the same to myself. So I'm the only user, but we can change the kinds of group, and then we can use staging group, so we can control the number of people who have access to it. While we set this up and set up the airbag configuration, that user will be also only limited to view the resources that we assigned to that user or group. So I have demo here and connect to that cluster element using non-admin configuration. So my current context is PRG9 AKS 01 without the admin. So I shouldn't have access to anything other than application namespace, and already in application namespace, which I set up and I put out the context. And I should be able to list the pods or deployments. So I'm seeing everything. However, if I want to get anything else, I should get information that this is forbidden, or even in this next spaces, which I don't have access to. Yeah, I can do that as well. So yeah, with that, I can control the access. And with that, yeah, I believe this is the end of the demo, so thank you.